is division. So when we do like 12 over 4, that's just 12 divided by 4, that just equals 3. Of course, we don't usually write 3 like this, so we usually use fractions for things that we can't express as whole numbers, something like 1/3, right? So this would be like 1 divided by 3. So let's think about what happens when how do they write this? So they kind of have this negative, it's not really clear, it kind of looks like it's out front. So like, basically, the negative isn't usually associated with the top or the bottom. It's just something is negative or isn't. And that kind of makes sense, right? Because if we have like negative 12 divided by 3, that's negative 4, right? A negative number divided by a positive number, the answer is negative. Right. But what if we just did positive 12 divided by negative 3? That's still negative 4. It didn't matter whether our negative was in the top or the bottom. The answer is still negative 4. It still means the same thing. So that's why a lot of times in fractions you'll see something more like this, where the negative is just out front, because we don't necessarily associate the negative with the bottom or the top. It's just the whole fraction itself is negative. So essentially the way you could think about it when you're solving problems is you can put it in either the top or the bottom. So we have like this, we have an x divided by like 6 or something like that, and it's negative. We could write it up here. We could write x.
So say if this is a number on top. Say if there's a number on here. Like say if it's like 3 divided by 6. And then just so that means negative on both, right?
3 divided by 6.
Yeah, and then this is a
negative on
sign.
the top. It absolutely does. It does not mean there's negative. Oh, so let's think about that. Good question. So what would happen if there was a negative 3 on top and a negative 3 on bottom, or negative 6 on bottom? Remember, this is division. So this is a negative number divided by a negative number.
Right.
What's the answer to that? Or is that answer positive or negative?
It's positive.
It's positive, yeah. So this is the same as this, right?
Correct.
Which is not equal to this. We're saying this whole fraction is negative. So when there's just a negative out front, it does not mean a negative in the top and the bottom.
What does it mean?
It means that...
Subtract the fraction?
It can if it's like x minus 3 over 6.
Would I ever run into stuff like this?
Sure.
So what does that mean when it's just like a negative and then 3 and 6?
Okay. Well, 1. 3 over 6 is 1/2.
Okay.
It's the same as 1/2, simplified. Okay.
Okay.
So when you see this, negative 1/2, so let's think about a number line. Let's think about a number line. When you run into something that's just this, you just see a negative 1/2. This is what this means. So you have a 0, 1, 2, 3, negative 1, negative 2, negative 3. What this means is just this place right here. Negative 1/2. Halfway between 0 and 1 on the negative side. That's all that means. So we have to be able to express fractional amounts as negatives, right? Because they can be, right? Like say I have an apple and I ate half of it. I need to be able to do 1 minus 1/2. I need to be able to express fractions as a negative as well. And so remember, that doesn't mean that the top and the bottom are negative. It just means that fractional amount is negative. So how do you use that idea when you're solving a problem? So let's think about that. So I'll just make up a problem real quick. Actually, what's the problem you're working on? It's this one. Okay. X over 10. Okay. So the first thing I'm going to do is I'm going to subtract this 2 from each side. And then I get this negative x over 4 equals 8. Okay. And actually, I'm going to rewrite this so the negative is back out front. So practically, remember that this whole fraction is negative, right? This is a negative x over 4. So practically, what does that mean? Well, when we divide something and the answer is negative, it means one of our numbers is negative and the other one is positive, right? So practically what you can do is you can take this negative and put it in either part that you want, whichever is going to be more helpful to you. So you could rewrite this as like, so you have this negative x over 4. You could rewrite this as negative x over 4 Or you could write this as x over -4. These are all equal the same thing. So whatever is going to help you solve your problem in the end. Technically, all these things are equal. They represent an equal idea for the most part.
Mm-hmm.
So yeah, so like in this problem here, I have this negative x over 4. I know I want to get x by itself, right? So I don't really want this negative up here with this x, because then the x is not by itself. It's being multiplied by a -1. So it's going to be more helpful to me if I'm thinking about this bottom number as a -4. So let me rewrite it like that. I'm going to write x over -4 equals 8. Then I'm just going to multiply each side by -4. I get x equals x times -4 is -32. And so this is like one of the cool things about math is this is a flexible idea. Like if we take a number and we divide it by another number and the answer is negative, it doesn't matter whether the first or the second number is negative. Either one of them being negative will give us a negative answer.
Right.
So that's why all three of these ideas are sort of equal.
Correct. So
the answer to your question, and I'm just going to go ahead and rewrite the problem I had before. X minus 4 plus 2 equals, I don't know what it is anymore. Okay, so the answer to your question is we could have done it the other way. Like, we could do like x over 4. We're going to subtract both sides by 2, get 8. And so we could have just done, we could just multiply both sides by 4. These cancel. So we could have had negative x equals 32. We just would have had one more step. This is like -1. Divide both sides by -1. X equals -32. It didn't matter which way we thought about it. We've got the same answer either way.
Correct.
And so this is...
So it doesn't really matter.
That's it. Maybe this way was one less step.
Okay.
But in the end, it doesn't matter. And this is kind of more... This is a little bit more in the direction of what mathematics should be like. It's like a set of like rules that are flexible. Like you could do lots of things. Like, right, we could have taken this problem. We could have done it a different way. We could have multiplied both sides by 4. And then we have to do, of course we have to multiply both of these by 4 now. Plus 8 equals 40. This is just negative x plus 8 equals 40. I subtract 8. Negative x equals 40 minus 8, which is 32. Divide both sides by -1. X equals -32. So as long as we're using the rules correctly, the truth is it doesn't matter what order we do them in.
Right.
It's just, here we have a bunch of fractions. Not at this time, actually this wasn't to it, but here we had to distribute. This was a little, like a tiny bit more complicated, right? So yeah, and this is more about what math is about. It's not like thinking, oh, I always have to do this first, I have to do this first. We have these rules, and as long as we're using these rules correctly, we should get the right answer.
Mm-hmm.
So yeah, so kind of a long-winded answer. If you have x over -4, the negative out front, you can put the negative up top, or you can put the negative down bottom. But it only goes in one or the other. It doesn't go in both. So you put it in both, that's the same as this, which is not equal to this, right? Because this is positive and this is negative.
Right.
Yep, there you go.
Okay.